Hello everyone, again another exciting session of COTI Developer Community Call. As always, we're very thrilled to have this session, talk to developers, share with you guys, the community, what we have been doing, the things that we are working on, all the possible directions we are taking to improve the developer experience over COTI new network. So let's go on. As always, any feedback is appreciated. Feel free to stop us, ask questions. We see messages on chat from time to time, so feel free to ask anything, shoot away. Recap from our last call. So in our last call, we've intensively talked about COTI contracts and COTI ethers, and Spencer showed us some of the changes we worked about it in those two repos, and he showed us COTI contracts. Eitan showed us the COTI ethers, and we are really pleased out of what have become of those SDKs. They are pretty mature. They are supporting MetaMask. They are supporting browser. And if you'll have time, we'll show you some more improvements and changes we done there. So, brief overview on today's content. I'll touch on that in a few minutes, just to keep everyone reminded. Development resources. So, docs COTI.io. We have an updated version of our documents. We didn't release it yet, doing some final fine-tuning, but you should expect much more detailed and enhanced documentation coming on later on, really soon. Testnet COTI-scan.io is our Explorer tool for testnet, our transaction scanner, block scanner. So let us know how it goes. Check out what we have been doing there. And so no one will forget, our GitHub is COTI-io. Check out the projects and the progress we are making there. As always, we really appreciate that you guys are supporting us. So please, do add us a follow on GitHub. Use the follow button as you see on the screen. Start your favorite repository. Those kind of things help us to understand which one of the tools you like better. Of course, any feedback is appreciated. Open Git issues in case you find, and we will address it, of course. So let's move on. Today's topic. First and foremost, everyone were looking forward to it. So we will be talking about the privacy on demand, cross-chain communication. Eitan will show us a demo about it, and I'll touch with a few words about it in a second. And if you'll have time, we want to show you a few more updates on the SDK. Basically, kind of a separation that we've taken for the ethers, for the Web3 Pi, entire ecosystem for development that we are progressing with, and we want to share the updates with you and what we've done there. So I got a question on the chat. What's happening in testnet? Increase in transaction and wallet? Yes. So there is some developments going on that requires immense number of transactions going on and making sure everything is running smoothly. So yes, that's happening, and it's for some product that will be discussed, I guess, later on along the roadmap, not today. So let's talk about privacy on demand. As previously announced, a partnership with Axelar to enable DApp developers having privacy features from remote networks into COTI. So that's in high level what's going on, right? So why is it privacy on demand, and how do we enable that? let's take two common cases, okay? The first one is where the private data, means encrypted, right, is stored on COTI chain. Now, how to store private data on COTI chain, you can check out the documentation. We have plenty of demonstrations and examples, and even the sandbox.coti.io. If you didn't get a chance to play around with it, please do. So that shows how private data is stored. So for the first use case, private data is stored on COTI chain. And the computation function that you want to do over that data is sent to be executed on COTI from other networks. Means you store the data on COTI as a DApp developer, and then you use some function, for example, let's say age verification. So you saved some user's age on COTI chain using a primitive called ctuint, which is basically ciphertext unsigned int. And then you save it on COTI, and then from another chain, you want to go ahead and ask about that data. Is he over 18? That's exactly what Eitan will be presenting today. The first use case where data is stored on COTI, and some DApp developer can ask questions about that data, and that opens a whole new world of possibilities, right, for DApp developers, because they can store the data, and based on action being done on their DApp in some other chain, they can get answers without compromising the security of the data. So that's for the first use case. The second use case is where the private data is actually not stored in COTI. It's stored on some remote network. And then the DApp developer sends a transaction that basically contains that data and the private function, the private computation function he wants to do, to be executed over COTI. And what does he gain out of that? He basically gains something very important. The fact that the data that he holds is encrypted. Okay, because the data he holds is encrypted, it's not in a risk to be exposed. So in order to use the data and compute over it, he needs COTI's garbling circuit. So he basically sends that data encrypted. No one knows what it is. He sends the function he wants to compute. And these two together basically form one single function of computing over that data and giving back the response. By the way, that data can be then thrown away, and it's not even saved in its AES format at all of COTI network. So you can even make sure that that is private also. So those two cases opens up a whole new world of possibilities for users to make sure that they can make use of any private data that was used or stored or held by them, and still be compliant with all kinds of regulations, as you're familiar, MiCA and HIPAA or GDPR, where you have no access to the data. The data is encrypted. Okay? Even if you lost the original data and you're just keeping the encrypted value of it, you can still use COTI in order to compute over it and make use of that data. So if you have any other further question about those things, we'll be very, very happy to answer and explain why COTI solves the privacy enigma on blockchains. So again, I'll be tuned in to the chat in case there will be any questions. I'll be happy to answer. And I think we can move ahead and let Eitan show us the demo. So Eitan, you'll excuse me if I'll stop you in between because someone will have a question, and go ahead and share screen. I'll stop my sharing.
Okay, I'm sharing. Hi everyone, I'm Eitan from COTI team. I'm a software developer, and today I will present a demo and explain how we are achieving the privacy on demand using Axelar network. To do it, we are using the GMP protocol that Axelar created. GMP is a general message passing with amplifier. In that case, amplifier is the Axelar new technology to send message from one network to another, from a source destination network, from a source chain to a destination chain. Here we can see a high-level diagram of all the flow, basically. In our demo, we will use Sepolia as a source chain. Currently, Axelar supporting other network. I will show you in a few minutes. And of course, the destination chain is COTI, and we will send message back from COTI to Sepolia. In this high-level diagram, we can see that in source chain, basically, it's an EVM compatible network. It can be a Cosmos network or other network. And what we are done here is basically we are creating a DApp. The DApp is asking a question on COTI, and COTI replying. COTI store the encrypted data, and COTI replying with an answer. As Guy said, our demo will be, we will ask if some person is over 18.
Just a second.
Sure.
So Pablo asked if someone shows up with the intention of doing something dishonest, like buying drugs, how will privacy cooperate with the authorities? So I want to really touch brief on that. We have a product, an extension, you might call it, something called Data Privacy Framework. Spencer, I think that also documentation is pretty much ready, right? We've even released the first version of the documentation on that. Or is it in the next Git book?
I believe there is some documentation already in the GitHub repository, but in the updated Git book, it will be much more comprehensive.
With the MPC support DPF, right?
Yeah.
Maybe you want to throw in some tips on what DPF is?
Sure. So DPF stands for Data Privacy Framework. I'll just go over it quickly so we don't deviate too much from Eitan's presentation. But basically, it's a great tool that we provide to smart contract developers that allows them to easily and effectively manage permissions to private data that is stored on-chain. So it's a nice smart contract library that you can use in your own DApps, and it will allow you to control who can access. Hello?
Yes,
No,
we can hear you.
you're audible.
Sorry, it said I disconnected. It will allow you to control who can access which values stored on chain, and to manage the permissions dynamically, basically.
So using DPF, you can basically define who can run which computation function on which data. So as a developer, let's say, you stored a whole bunch of data points, and you can decide which data is accessible by which function, right? We have add, subtract, divide, multiply, shift left, shift right, decrypt, even decrypt. So we can control using the DPF on which wallet can do which action. And why is that important? Exactly for Pablo's question. Is that correlating with authority? So the DApp developer can basically decide to integrate the DPF And by doing that, Pablo, he can set few wallets like of the regulator to be able to compute over the data using functions like decrypt, and only that wallet could do that the whole time. So depending on the level of regulation, on the level of compliance that the app developer wants to be, he has the tools to do that. He has the tools to expose the data as much as needed, and to do that to regulations, to their wallets. If it answered your question, great. If not, please let us know over the chat, and we will talk about it. I see Nicholas also asked a question about malicious encrypted backdoor. So he's asking that if a developer makes a contract around a token with rules about locked supply, but also coding an encrypted backdoor allowing him to unlock a portion of the locked supply. So see, here, Nicholas, again, I think it's a matter of audits, right? Because once someone releases a token, you might want to use that only if it got audited. Now, there are companies that we are already discussing on how to audit our GC technology and the new EVM precompiles, so they could tell you exactly if there is a backdoor or isn't. Now, even if you will try to use encrypted data in order to create some backdoor, by analyzing, by auditing that contract, you could know that, because the actions that you will do might be malicious. I want to remind everyone, COTI private network, privacy preserving, does not mean that the contracts themselves are private in a sense that they cannot be seen. Contracts are the same thing like in Ethereum. You can read them, you can decompile them, and so on. So the contracts, in the sense of code usability or developer approach, same thing as Ethereum. The addresses that you send and receive transactions, it's not anonymous. The addresses are not concealed. So those are two important things. We are transparent in the sense of addresses, and we are transparent in the sense of the contract contents, right, that you can decompile, but the data that is saved and the actions that are done, those are considered private. So Pablo and Nicholas, I really hope I answered your questions. Okay, another one by Nicholas. Does it mean that the projects that are being built on COTI ecosystem for grant program will be eventually certified as audited? Now, see, we will be happy to discuss the option to certify, to audit projects that are part of the grant program, if it will be applicable for a grant and for a grant for an audit. Depends on the project. Daniel is not with us today, our head of product, but I'm sure he could elaborate more on the RFP programs and so on. And Joshua, our head of ecosystem and partnerships, who is basically leading the grants program, could share lots of more data. Feel free to ping me over Telegram, and I'll make sure to connect you, Nicholas, if you need more information about that. Pablo, this sounds quite interesting, but for example, the transaction I currently see on Etherscan, will I see the same way? Okay, so I'll just say a few words about that, and then I'll let Eitan continue, because I think I took too much time. You will see almost the same data as you see in Etherscan. Yes, but what will be different? The data itself, like in Etherscan, when you open the transaction, you can see that the data that was sent, right, to the block itself. The transaction contains data, and the data is part of the block, so you can see the data. When looking on encrypted data, it will just won't make sense what you're saying, because it will be a composition of text, let's say, that won't make any sense because it's encrypted. So that's the similarity to Etherscan. You will see addresses, and you will see contract addresses, and you will see lots of stuff. But specific data that the developer will choose to encrypt, you won't see reasonable data. You will just see a collection of text. That means it's encrypted. Now, how can you really technically know it's encrypted? You'll have to go to the actual contract and see that it's type of CT unit or GT unit or IT unit. And there are more explanations about that in previous recordings if you want. Eitan, I took too much time. I know. Go ahead. Go ahead. Thank you.
Okay, so as I said, the source chain is EVM compatible. In our case, it's Sepolia. The DApp that I deployed is a simple Solidity contract. We also deployed an external gateway. It's also a Solidity contract. I will show it a little bit in a few minutes. When the source chain is Sepolia, we are using Axelar relayer, but we created one for COTI. Basically, the relayer have two components, two main components. One of them is a component that interacts with Axelar GMP API, and the other component called Network Block Explorer. Basically, it looks for specific events on our network and do action and relay them on Axelar or execute it on COTI. Also, we created something called AMPD. AMPD is a daemon on Axelar, and this daemon have two main responsibilities. One of them is to vote on your transaction. If you are sending transaction from Sepolia to COTI, someone need to verify. I'm talking about this part basically. Some component needs to verify to vote that your transaction is valid. The other job for this daemon is to create a proof for the destination network. Let's say you are sending a message from Sepolia to COTI. The Sepolia verifier is voting that this message is valid on Sepolia. It's routing it using all the components in Axelar. And finally, the COTI multisig, the external verifier is creating a proof for this message, and this approve is being sent to COTI gateway contract. So every contract can basically query and get the proof and to see if it's valid, not valid, and do with it whatever you want. Okay, so a little bit about the Axelar, the contract that we deployed on Axelar network. We deployed 3 contracts. One of them is the multisig, other one is the voting verifier, and the last one is the gateway. All the contracts are written in Rust, compiling with WASM. I forgot to mention, Axelar is a WASM network, custom WASM network, basically. So if we can go over the method that this Rust contract is exposing. We will see it in some of them in a few minutes. So as I mentioned, the gateway, the voting verifier, and the multisig prover. 3 contracts we deployed. This is the voting verifier we deployed, the gateway, and the multisig. 3 contracts. Okay. And let me open the Solidity. I can send links to Axelar repos a little bit later, or maybe I don't know. We can put it in the chat or send it. Not sure, Guy, what is the preferred way. Here we can see the gateway contract. Let's go to our high-level diagram. This external gateway, it's basically it's the same contract. It's handling if COTI is the source destination or if COTI is the destination chain. So this is the contract. We have a proxy. First, we deploy the. Let's start with the implementation. This is the external gateway implementation. This is a Solidity contract. It has a few, let's call it this, a few important methods such as approve message. This one, after the voting verifier is voting for the message, it creates approve message on the destination contract. Another is called, it's not here, 1 second, it's in the base contract. This is basically pretty call contract. This is happen when this event is emitted. You know what? I will say it again. When your DApp wants to communicate or send a message to another network, it must emit event that called contract call on the gateway. I will show example in a few minutes. I think this is and it has another method that called execution, just to write that the message has been executed on the destination chain. Another important thing, if one of you want to create a DApp and use the GMP protocol, it must extend. It must extend the Axelar executable currently. This is the implementation. So we must extend this interface. What I forget? Any question? Maybe in the chat. Okay, so just stop me. Feel free to ask anything if something is not clear in the contract, or maybe you want me to go a little bit deeper with my explanation. Trying to create a demo that will fit for everyone. Okay, so I want to show you another thing. Basically, we started a Linux environment. This is how our daemon looks like. If we go back to the high-level diagram, what I'm talking about is this one. The external verifier, the daemon that is voting for your message and creating a proof for your message. This is how it looks like. Currently, we are supporting COTI. We have only one daemon for voting and creating the proof. If there are more than one, the Axelar protocol is taking the majority of votes. Let's say we have 3 daemons. 2 of them vote yes. 1 of them vote no. For some reason, I cannot think of any reason if everything is valid. So the message will be routed. If the opposite voting is being submitted, the message will be rejected. Okay, great. I will show you. You see here, basically, it's getting a message to sign, but it's saying I'm not a participant in this message routing. Not sure for which network or for. It's basically not a message that don't route to COTI network.
Just a sec, Ethan. Nisi over the chat has a question. Does the developer have to write both Rust and Solidity code? Which component does the DApp developer have to implement? So maybe you can first touch base on that and explain exactly.
Sorry, just let me read. The developer have to write. But no. You look. The no is not so restricted. If you are, let's say, want to route from a source chain that is CASM WASM, you need to write your DApp in Rust. But if you, so I'm talking about this your DApp, okay? Or so this one is you need to write it in the language of the source chain. In the destination chain, COTI is an EVM compatible, so you need to write it in Solidity. We are writing and maintaining the contracts that deploy on Axelar. Currently we deployed 3 contracts. You don't need to touch them, and basically you are using them.
So just to refer to his question, he, as a DApp developer, will only need to develop, let's say, the Solidity contract, for example, in Sepolia, and the Solidity contract in COTI side. That's it. As a DApp developer, you'll have to only develop the Sepolia contract for your DApp and the COTI contract for your DApp to save the encrypted data, for example, the private data, and that's it. Now, you will need to know how to interact with our contracts, so message will pass from Sepolia to COTI and from COTI to Sepolia. And of course, we will later on publish a demo application, demonstration of contracts that shows how to send data between chains.
Here is an example, basically, of a DApp. This is a simple DApp. I deployed it on Sepolia. As I mentioned earlier, I extended the implementation, but if you are writing a DApp, you must extend the Axelar executable or the interface. If you can see here, when we are building or deploying the contract, we must provide him the address of the gateway. What is the address of the gateway? This is the address. Basically, your DApp need to do whatever logic you wrote. You wrote for your DApp, and at the end or in some point, it must emit an event for the external gateway in the same way as I did here. Okay, so basically you are calling, sorry, not event, you are calling the call contract method on the, sorry, let's go to the Solidity and call, and it's not here, it's in the here. So you must call the call contract method on the gateway. This is basically what this is a simple method. The only thing that it's doing is emitting an event called contract call. The relayer on Sepolia or the relayer on COTI is looking for this event and basically starting the whole routing flow. Sorry. Nisi, I hope if it answers your question. Just write if you have another question. Okay. On the other side, on COTI side, basically this is my DApp. It's the same DApp, but when we're executing the message on COTI, what we are doing here is we are using I will show the data in a minute. But what we are doing is basically we are taking an encrypted date and check if this if the date is greater than 18. We are storing the information in a map. Let's say Ethan is the date of birth is I don't know. It should be in epoch time, basically, according to the implementation, the current implementation. Sorry, I'm here. After we are checking, basically, I'm returning a message back to Sepolia that's saying true or false. Ethan Ethan age is greater than 18 or not. I think a little bit earlier, someone mentioned about the encryption. I can show you that. Let's say I have. Let me check 1 second that I'm on COTI network. Sorry, using the MetaMask. Okay, I'm on COTI. Let's say I want to add another person. Let's call it Alice, and its date of birth is, I don't know, 2014. I don't know. It can be anything. So this is the epoch time. I can put it here and just transact. I'm calling the set date of birth. The set date of birth is basically taking the uint of unencrypted epoch time, encrypting it, and store it in a map. Let's do it. I will sign the message. The remix will let me know when the transaction is in the block. Great. So let's check, and you can see that this is the number. This is the epoch number that I added for Alice, and this is how it's stored in COTI. No one can understand the date. Now, if you are asking, okay, so basically someone can go to the transaction and see the value. You are correct, but you can encrypt it using your AES key, so nobody will be able to see it in any. Sorry, let me correct myself. He will be able to see it, but he will not understand the value. The value will look like that. What else? Any question, guys? Okay, so let's start. Okay, so what I'm doing is basically I'm taking the, let's recompile it, and sorry, and use this one. Let me take the address. I already deployed the Sepolia just to save time. I already deployed the DApp on Sepolia, and let's check. Okay, so this is the information that every GMP needs to have. The destination chain. Remember that I'm on Sepolia. Sorry, let me change to Sepolia. Okay, so you can see I'm on Sepolia, and now the real address. And okay, so I'm on Sepolia. I want to send message to COTI. Currently, COTI-7 on DevNet, on COTI DevNet, and also on Axelar DevNet. We are working to get the old system working on testnet. You need to mention the destination address. The destination address is I already deployed the DApp on COTI. This is the same as test check. So this is the address, and I want to check if I don't know, Ethan is over 18. Or you know what? Let's check if what I deployed. If Alice, let's send Alice. Oh, Alice. Okay. So we are transacting it. We are signing the transaction. in a second, Remix will let me know that, that the transaction, okay. And we can see it on Etherscan. In a minute, when it will be included in a block, we will see the event that we sent. Great. So here you can see the payload. We can basically, the payload is encoded in to a byte stream. You can see I sent Alice basically. If I'm decoding it to string. Okay, so what we did here, we send the message to Sepolia. Let's see what happened. We can go to DevNet to Axelar scan. We can see that the message. This is the DevNet amplifier. Now what? Let's talk about it. Let's say a few words. Basically, we have Axelar created this great explorer. You can see here all the networks that connected. We have Solana, we have Momentum, Multiverse, and other Optimism and other network. Basically, Axelar created a relayer for all the network. Some of them private companies created, such as the Multiverse X is another company that deployed their GMP contracts and do GMP over Axelar. And that's it. Here they have a section that's called general message pathing. You can see here the message. If you click the TX hash, you are redirecting to another nice page that show you the whole routing message. Now, because the finality on Sepolia or Ethereum is basically set to 2 epochs, and Axelar, the security of the network is very important. So two epochs is basically about 15 minutes, so 16 minutes if I'm not wrong. So this is the time that is taken to the message to be discovered by Sepolia relayers, and the relayers starting the flow over Axelar.
So basically, just one question there, Eitan. So the time it takes the message to go through, it's basically dependent on the relayer by Axelar. That's what you're basically explaining.
I'm saying we did, yes, exactly. We did not create the Sepolia relayers. Maybe in the future, and we can set another finality time. But with the discussion that I've done with the Axelar developers, this is what they decided, to wait 2 epochs until this message is considered as confirmed.
Okay, so it's basically it's a relay, it's an Axelar relay definition to wait those 2 epochs, right?
Right. So in order not to waste time in this in the demo, I previously created you know what, let's filter it for a second, it will be more easier. Destination source chain is COTI and it Sepolia. Before this meeting, I created if you can see here, about an hour ago, I created a message and stop our relayer. In order that, let's go to this GMP page. You can see that it's stuck on approving. What does it mean? It means that my AMPD signed the transaction. We will see it, I think, up to the end of this to this demo. Maybe a little bit up. I can show you how it here. See, this is how the signing looks like. So basically, I approved the message, but I didn't route it to the to COTI network. If I'm starting the relayer that we created on COTI, we will see it proceeding. So let's give it. I just started it. Let's see it. Basically, let me talk about this page. This is a nice page. Every step that you can press and see the transaction and see all the transaction information. The sent is basically the transaction that's sent from Sepolia to COTI. Pay gas, you can see it's not marked. What pay gas means? It means that, I'm not sure if we can see it in the diagram, but someone need to pay for the transaction. Currently on DevNet, Axelar and also COTI, we are funding the transaction. We have account and we are funding the transaction. On testnet and also on mainnet, you need to pay for your transaction. You can pay it on, let's say, on Ether Sepolia, and the gas service will convert it to first to Axelar in order to have enough money to send the transaction over Axelar. And the other one, the relayer, will use a gas service for COTI to basically to convert Sepolia to COTI, to fund the transaction on COTI.
Just to mention one thing there, Eitan, I think maybe you could throw in a few words about it. The gas station, the gas service that will be deployed later on in production will basically make sure to fund it himself. Like you will give it, let's say, Ethereum tokens, and it will use that to fund the AXL tokens and then the COTI tokens, basically, right?
Right. Basically, we are not. No one expecting to that the user or the DApp on Sepolia will have I don't know, COTI or have an AXL. So there is a gas service that's supposed to convert the destination chain asset to Axelar asset and also to the destination chain asset. You can see here basically that the message got confirmed and approved and executed. If you press the executed, you can see you will be redirected to, you see it just happened now, a minute ago. You will redirect to COTI Explorer. You can see all the details. As I said, let's go to the contract. Here in the contract, we are checking if the age of our user is greater than 18, and we are sending a message. You see, this is the I'm calling the call contract on COTI gateway, and this, as I showed a little bit earlier, this emit event called call contract, and you can see it here, basically. It's
just a question, Eitan. So the data we see here is actually encrypted?
This data? No.
Yes.
No.
Okay.
I'm sending a true or false. So no, I'm not encrypting.
That's what you're sending back, and basically you are the data that you're calling with. What's the parameter?
Which parameter? The data that I'm calling. The source change, the source address, and the result. This is the data.
So basically, you save the data encrypted. You give it some input, as we see in line number, I think 77, right? Using the date of birth of name, you onboard the data, and then you compute over it, and then return it. So could you show us the actual data that's sent back in the event? That basically means it's encrypted?
The data return is not encrypted. If I will take this one, sorry. Now what? Let's see. Guy, I will show it in a minute. You can see, basically, you can see this message returned back from COTI to Sepolia. And one great thing that they did, if you will press it, you will see the all route of this message from Ethiopia to, the whole flow. You can see when the message will be executed on Sepolia, I can show you the payload that I sent. It will be true or false in 1 second. Same thing is happening on Sepolia. The approve, the confirm. You can see here that this time I vote for this message. Also, one great thing that Axelar did is they are showing you the voting. You can see here that for this message, I have one yes vote. So this is what you see here. The COTI AMPD vote for the message back to Sepolia. Let's see if our message got executed. And you can see here, we can see we can see what's sent back. Let's take this payload to our converter, and you can see that the value false is being sent. If you remember, basically Alice is 10 years old.
So that's why she's not greater than 18.
Okay, exactly.
So basically, Eitan, you showed us now a demonstration of a contract asking about confidential data, about her age, for example, whether she's greater than 18 or not. Now, the answer, the reply of true or false is sent decrypted. It could have been also encrypted, right, with the same key of the user?
Yes, basically I can return the answer encrypted using the user AES key, and on Sepolia, he can decrypt it and see the value.
His AES key that he acquired from COTI network.
Yes, this is a maybe great example for next time.
Just before you continue, I see a question here by Nisi again. Does the routing of the transaction through Axelar introducing a latency? Nisi, I want to talk about that. We mentioned it. For example, the relay that's basically relays stuff from Sepolia to Axelar. That's a relay that takes 2 epochs in order to make sure that the Ethereum Sepolia transaction has reached finality. So it's very much dependent on the relay that's handling your transaction. For example, that relay requires 2 epochs. Maybe COTI will introduce its own relay to Sepolia. Maybe Axelar will change it. It's too early to say. Now, also latency is, it's a term that's configurable. I mean, one might consider a minute as latency, and another one might consider 10 minutes as a latency. For now, we can tell you that Axelar is using a relay that requires 2 epochs. Maybe COTI will introduce its own relay, for example, for Sepolia, for Ethereum, and so on, and then it will work faster. We're still checking on all of those details, making sure we do the right decision from finality point of view. And then you ask, is it a bottleneck? Yeah, it very much depends again on how fast do you need the response to the transaction from Sepolia to COTI and then from COTI to Sepolia. I see another question by Grizzled Crypto. Yes, so the gas service, everything happens automatically. You basically fund the transaction using the contract, for example, in Sepolia. You're paying the gas token, and that will be converted by the gas service to AXL to fund the Axelar transaction and then the COTI transaction. Right, Eitan? That's the way it happens?
Right. You will have to send some money in the value. The method on the call contract method will define as a payable, and it will take the money and convert it using the gas service and send the message to the other networks. It also the gas service must have a refund mechanism. So let's say your transaction is not valid for routing. So we need to refund your account on Sepolia with the money that you paid to send the transaction on Axelar or the destination network.
Okay,
Or maybe you paid too much and you will get refund.
hi Soen. 2 epochs, about 15 minutes, Satan?
Ethereum finality.
It's 6.4 minutes, by the way. It's 6.4 minutes. That's the epoch time. And approximately 13 for finality.
About 50.
2 epochs, yes.
Yeah, about 15 minutes. I think Axelar have some another grace period, or I don't know how to call it. I saw the average is 17 minutes, something
great.
like that.
We have 4 minutes left. Anything you want to show more? If not, of course, we will have another session in case we didn't cover everything. I wanted you to focus a bit on the method, the confidential method, just letting everyone understand what was done there. If you could, we won't be able to reach COTI contracts or COTI editors. Sorry, Spencer and David, but the privacy on demand it's a hot topic. Maybe you could just briefly go over the confidential method so everyone will pretty much understand why is it private data.
Sure. So let's see first the set date of birth. What we are doing here, we are sending unencrypted data. Basically, you can use here the ITUIN64 and encrypt the data before you are sending, and it will work. So what we are doing here, we are taking the date of birth and we are setting it as public. What does it mean? It encrypted using, Guy, correct me if I'm wrong, encrypted using the network key.
Yeah. Well,
just
to mention one thing, because I really like to be precise. So the set public takes an unencrypted data and saves it in a GT form. Now the GT form is not exactly using the AES key as it is. It's we like to call it a transit state of the data. Only when data is in the state of a GT, of garbled text, then it's computable. Then you can use that as an input to some function that computes over garbled data. Okay, so input text is the ciphertext representation and city is the ciphertext representation, different AES keys, but garbled text is the transit state where the data is between function, between loading it from encrypted state, either IT or city, computing, and then reverting it back to either IT or city. So a little differentiation there.
Yeah, and when we are checking basically this value, what we are doing is we are creating a GT object. This GT is containing an object that is computable over the GC, the garbled circuit. This is a method that checking greater than. What I'm doing here is basically I'm taking the timestamp of the block and reduce from it in 18 years, and see if the time of the block less than 18 years is greater than the date of birth, and that's what telling me that is larger than 18.
Again, I'll just mention, I know you did, the greater function, greater equal you use, is basically computing over the garbled data, which means it's not decrypted. No one knows what's there, but that's the garbling circuit magic where you use one clear input, one garbled input, and then you still get an answer back.
Exactly. So I'm just checking if the Boolean value is true or false, and sending back, encrypting it as a string and sending back. I think I will enhance this demo just to encrypt this value using the user AES key, the user that sent the message, and we can see that the response is returning encrypted, and no one can understand it.
Super. Maybe that's something for the next session. We are almost out of time. Eitan, maybe you can stop sharing. I'll share again.
Sure.
I just want to finalize today's developer call.
And disable screen sharing.
Thanks. So we wanted to touch base on those other topics, but we didn't get a chance. So we want your feedback. Please, developers, open GitHub issues. Anything you find disturbing that you want us to do differently, that you want to talk about, let us know. We are available also on Discord and Telegram. We pretty much prefer Discord as a development-oriented channel, and of course GitHub issues. So we need your feedback, and let us know. They get involved. So we'll publish later on the RFP opportunities. It's a COTI grants repo. Take a look, and the builder program also, it's available. We will publish that in the Medium article post this session. Questions were answered, I hope, and if not, we are there in Discord. Thank you very much for joining this session. If you have more questions about privacy on demand, we are thrilled to introduce this capability for COTI and for the blockchain ecosystem in a whole. And stay COTI. Thank you. Bye for now.